Tom just saw Mark 50 feet away of a 100 feet tall building. So he threw the ball over horizontally at a speed of 50 feet away over second. Okay, so we need to get the equation of motion in the y direction. Then we use the derivative over this equation. We calculate the time, the final velocity or impact velocity in the y direction, the distance of the total distance that is Mark through the ball, and the position and velocity of the ball at time of 2 seconds.
So first we're going to write down our data table to know what values we have and what we're gonna need. Okay, so now that we have this data, we can know what formula is the one we need to use, and it's gonna be this one. It is basic physics formula, and we know that the initial velocity of y is 0, so this is 0, so time also cancels, and now we have that. Okay, so this is our first answer right there. So the second thing they're asking us is time, and we can totally get time from this equation. When we isolate time, so we know all these values, so we can get time. And the time is equal to 2.49 seconds. The third thing we're being asked for is the impact velocity. We know that the velocity initial in the y direction is 0, so we cancel this, and when we isolate, we get this same term, but we have to get the square root of it. So again, the final y direction is equal to square root of 2 times 3 equals 5, and this is equal to 2 times 32 is 2. Sorry, 2 by 32 is 15 squared times 100, and this is equal to, what's the final y direction is equal to 80.19 feet per second. So now we've got the third thing we're asked for, and it's velocity final. Right, so the fourth thing we're being asked for is the distance the ball gets away from the building in the x direction. So this is our formula. We know the velocity in the x direction, which is with the one the guy throws the ball horizontally, and we know the time it takes falling down, so we can just substitute these values. And we get the result that x is equal to 124.5 feet. So the last part we're being asked is to calculate the distance the ball is traveled when the time is 2 seconds and the velocity it has. So to do that, we have this formula, and another formula in the x direction. So in the x, we're going to use x equals. We know the x direction is 50 feet per second, and the time that for the is 2 seconds. So has 100 seconds, and x equals 100 feet. So in 2 seconds has to travel 100 feet. And the next thing we're gonna do is calculate the distance in the y direction. Substitute all these values. We just have this, and the result of that equation is 0.3 feet. Finally, to get the velocity in the y direction, we know the initial velocity in the y direction is 0. So curiously, we're going to have the same result. So velocity in the y direction is 64.3 feet per second squared. So these are going to be our three final results we're being asked in the last question. So now we're going to explain how to get that derivative.
This is the formula. I write it right here. Then we substitute the values. We have these values. Then we solve the the parentheses and the divisions. We got this. Then we eliminate the hundreds because they have different signs. Then we solve the parentheses. We got this. We obtain these two similar values, but they have different signs, so we eliminate them. Then we factorize these two. We eliminate the h. So this value, we change it over here. Because h is 0, we eliminate this one, and this will be our result. I write it over here. 32.15 feet per second squared times time.
From Jamaica to the world,